All right, welcome back, team, to the Building Lifelong Athletes podcast. Thanks so much for stopping by. I really appreciate it. We haven't had the chance to meet yet. My name is Jordan Rennicke, and I'm a dual board certified physician in family and sports medicine. And the goal of this podcast is to keep you active and healthy for life through actionable evidence-informed education. Today, we're talking all about sweeteners, right? So the non-nutritive sweeteners is what we're kind of talking about, whether it's the ones you've heard about, monk fruit, stevia, Splenda, all those fun things. We're going to talk about them today, but first of all, why are we talking about? Well, there's been a huge shift towards these non-nutritive sweeteners, or NNS. So huge one, driven by the increases in obesity and type 2 diabetes everywhere. We're saying, hey, if we can have these things, it may be helpful to help decrease the risk of developing any of these conditions. And so it's led to a huge popularity of different options of these, chemical ones, synthetic ones, to the more plant-derived ones, and lots of in between. And so there's a huge need for these, and they're huge, they're just really popular because they're in all the food and that makes things sweet, right? They don't add any calories. It's how you get a good sweet taste without adding any calories. And so that's a big thing. And it kind of creates a paradox though for the modern consumer, right? So on one hand, public health campaigns target the harms of excess sugar, right? They're saying, hey, we have tons of that. So what happens with the food industry then promotes these non-nutritive sweeteners as a key part of the solution, saying, hey, sugar's bad. Well, we got something that's tastes like sugar, but it's not actually sugar. And then on the other hand, though, a large majority of people on the internet and in the world kind of worry about these things. They worry about these sweeteners and they have deep suspicions, right? They're like, well, these aren't natural. What do we do? And so it's kind of this zero-calorie conundrum, right? So products marketed with a health halo, I'm saying like, hey, these are a better alternative, but also people don't trust them. So it's kind of this weird situation there. And so on top of that, we have other ones that come in like these natural ones like stevia and monk fruit saying, hey, actually, they're more natural and they're better for you. But there's a common perception that these are somehow healthier for you. And they're not really synthesized or processed compared to artificial sweeteners. We'll talk about why that's not necessarily the case. And yeah, it's just overall, there's a different way to look at it. A lot of people say, hey, this is natural sweetener without understanding that there's a lot of nuance there, like most things are. And so that's what we're going to talk about today on the podcast, kind of dive down deep and look at it. So the goal here is to kind of move beyond just that one underlying statement that, hey, these are good or these are bad. We're going to dive into evidence for what the sweetener landscape looks like. We're going to talk the origins of them, how they're processed, regulatory status, health effects, all these things. And so the idea is, the goal today is to understand the distinction between a sweetener's plant source and purified processed chemical extracts that are actually used in commercial products. We're going to understand which sweeteners are actually out there and what kind of category they fall into. And so that's kind of what we're going to go with here. So first, it's important to define categories, right? So it's important to understand that these non-nutritive sweeteners have a very diverse group of compounds, right? So it's not just a single entity. It's not like, hey, sweeteners, there's a bunch of different ones. There's differences in chemical structure and metabolic structure. But a lot of times they're kind of grouped together, which is kind of confusing because it's not the same. And so broadly though, they're classified into three main groups based on the origin and structure. So first we have the synthetic or truly quote unquote artificial sweeteners. The definition here is these are chemically synthesized compounds that don't exist in nature, meaning these are straight up made in a lab. That's where they create them. And the most well-known and longest used category by far are these. So these artificial ones have been around for a long, long time. So common examples, I'm going to give you some generic names and then some brand names because it might be helpful. We have saccharin, that's sweet and low, aspartame, which is equal or NutraSweet, and then we have acesulfame potassium, or ACE-K, that's an easier way of saying that. We also have sucralose, which is like Splenda, and then we even have newer, more intense sweeteners, include neotame and advantame as well, which are just, I like the term advanced or intense sweeteners. Like, this is intense, this is America, we need intense sweeteners. But those are the big ones here. So, right, we've all heard of those things like equal, ACE-K, sweet and low, Splenda, all those things. These are the artificial sweeteners. Then we have sugar alcohols, right? Or polyols is the name. So these are carbohydrates structurally similar to both sugar and alcohol. So they share some commonalities there. I'm not going to go into that in the biochemistry because, quite frankly, nobody wants to be bored by that. But they are poorly absorbed and metabolized by the body. So they're found naturally in some fruits, but typically manufactured for commercial use. Common examples include erythritol, xylitol, sorbitol, and mannitol. And the key characteristics here is they are less sweet than synthetic sweeteners and can cause a laxative effect at high doses. So if you have not done this, after this podcast, search Haribo sugar-free gummy bear reviews. Please do that if you've never done it. It's the funniest thing. It's just reviews of people saying, oh my gosh, what was in here? Well, it was a sugar alcohol. So since they have a laxative, so people were eating these gummy bears and having just massive diarrhea. And the reviews are one of the funniest things I've ever seen. Actually, I'm going to link that in the show notes because I have to find that because it's just hilarious. But they can be a laxative effect at high dose. So they're less sweet, but these are also very, very common as well, which we'll talk more about. And finally, we have the natural or plant-derived sweeteners. So these are the ones that were commonly starting from sort of plant. So first we have stevia, right? Everyone talks about stevia, typically from Paraguay, used by indigenous people for over 1,500 years. But the commercial product bears little resemblance to the actual raw leaf. So usually it's like a stevia raw leaf. You'll see like pictures of stevia on things, but like that's not what it is at all. It's very, very processed. So there's a huge process. These dried leaves undergo hot water extraction and then extensive filtration and purification with solvents like either ethanol or methanol to isolate the sweet molecules called steviol glycosides. And the final product is a highly purified crystalline powder that must be greater than 95% steviol glycosides to meet regulatory standards. So super process, but does become pure at the end. But the big distinction here is whole stevia leaf or crude extracts are not approved as sweeteners in many places, including the US. So we kind of have to tweak some things as well. And then on top of that, we have monk fruit, right? So monk fruit is a small melon-like gourd native to southern China, cultivated for centuries, right? So it's actually attributed to Buddhist monks who were early cultivators. It's kind of what they're named after, monk fruit. And is also processed, right? So first the fruit is crushed and extracted with hot water. Juice is then filtered through resin columns to separate the concentrate and sweet compounds called magoricides from sugar and pulp to get that sweet thing. And then at the end, the final product is a powdered extract with a standardized high concentration of those magoricides, as I mentioned about. And then a critical issue, though, we have to talk about is product formulation, right? And so purified stevia and monk fruit extracts are hundreds of times sweeter than sugar. So only tiny amounts are needed, right? So hundreds of times sweeter than sugar. Sugar is pretty sweet, and this is 100 times. So like you can't have too much. And so to create a product that measures like sugar, meaning like understanding like taking a spoon of it or whatnot, these extracts had to be combined with something, or like something called a bulking agent. So it's kind of like nothing, but then we kind of add to it. So most common bulking agents using top brands, there are a couple different ones, but one big one that previously has been used is called erythritol, as I mentioned before, the sugar alcohol, like we mentioned. And what's interesting is it's kind of this weird paradox again. A consumer buys a natural sweetener, right? So it's stevia. They're trying to do the right thing, saying, hey, I'm buying stevia. It's natural. They buy for health reasons, but unknowingly are consuming a product where the vast majority of the volume and weight is actually erythritol, something entirely different. And this masks actually potential harm from the co-ingredient erythritol, as we'll talk about previously. But people are buying this product to be healthy because it's natural, and they're getting something completely different, but actually like maybe more, maybe more of a difficulty, more challenge there than it may have more harm than we hopefully have in other sweeteners. Like the erythritol is one that we'll talk about, is kind of worrisome at times actually. And so you're trying to do the right thing. You buy this, all of a sudden you're erythritol, and you're like, oh, what the heck, man? So, but that's the general landscape of what we're looking at here. Next, I want to talk about the different, health claims we're talking about. So first we'll start off with cancer. So where did this start? So this is definitely the most enduring public fear, right, about these sweeteners is linked to cancer. Nobody wants cancer. It's an awful, awful, awful disease. But people are worried about that. And it kind of traces back to the 1970s, right? So there were early studies linking an early banned sweetener that's now banned in the US in very high doses to bladder cancer in laboratory rats. So essentially lab rats were growing some bladder cancer, and people were like, oh, they're worried about it. So, however, it was clarified later that wasn't the case, but it established a powerful and lasting narrative that artificial sweeteners can carry hidden cancer risks. That's what they're worried about. So as I mentioned before, saccharin in 1970s, studies show that extremely high doses of saccharin fed to male rats could cause bladder tumors. However, subsequent research discovered that the mechanism was unique to strictly rats, involving a reaction with their specific bladder physiology with high pH, protein, calcium phosphate, all this stuff. But long story short, this physiologic pathway was not relevant to humans. And so we found that like, hey, actually this can't happen because it doesn't happen in humans. So there were then a large scale human trials and epidemiologic studies that were conducted, which consistently failed to find any association between saccharin and bladder cancer in people. So based on this overwhelming evidence, this human evidence, saccharin was removed from the US National Toxicology Program reports on carcinogens, and the warning label was removed in 2000. But it's a powerful reminder that an alarming finding in an animal model is a starting point for investigation, right? Not a final conclusion about human health. We see this all the time. This happens on the internet where we see a rat study and we want to extrapolate it to humans. And I'm not saying we can't do that, because that's how we start the scientific process a lot of times, but making that jump saying, hey, we saw this in rats to here, we can't make that. We see that a lot in the longevity space. Like, oh, look what happened to these rats. Like, therefore it should happen to humans. Like, well, that's a lot of steps up before we go from rat to human. So this is just something you'll see a lot of people talk about. Say, hey, this, if you're looking for a study, see where it was done. If it was done on rats or on animals, well, then we probably have a little bit to go before we can extrapolate that. And so now let's move on to aspartame. So people talk about it all the time. This was, been debated for years. It kind of was reignited in 2023 when two different arms of the World Health Organization released seemingly conflicting reports. So just to make things more confusing. So first we have the IARC, which is the International Agency for Research on Cancer. So their job is to provide potential hazards. So it asks the question, can this substance under really any circumstance cause cancer? So they classified aspartame as group 2B, so possibly carcinogenic to humans, based on what they deemed as limited evidence for a link to a specific liver cancer in a few human studies. So their job is to say, hey, could this potentially cause cancer? And they said, hey, maybe, possibly, we're not sure based on this data, possibly. And then we have, on the other end, we have the JECFA, or the Joint Expert Committee on Food Additives. And their job is to assess real world risk, right? Asks, is this substance safe at typical levels of consumption? That's their main question. They concluded that there was no significant or sufficient reason to change an established acceptable daily intake of 0 to 40 milligrams per kilogram of body weight of aspartame. So essentially what they're saying is to get above the worrisome level, a 155-pound adult will need to drink more than 9 to 14 cans of diet soda every day to exceed this limit. So it's a pretty big limit. And they're saying, hey, we don't think that that is what's going on. However, what made it kind of confusing is the FDA publicly disagreed with the IARC, right? So remember the IARC said, hey, it could potentially cause cancer. Maybe based off of some liver studies that we saw, but the FDA swooped in and said, well, they disagree with that. And they reaffirmed the position that aspartame is safe and cited significant shortcomings in the studies that the IARC used. And so the core confusion is that a possible hazard does not equal a tangible risk at normal consumption levels. Potentially explaining the difference is really key to understanding this, that, hey, because there's mechanistic plausibility, that's always an option, right? Does it pan out? And that's the $1 million question, right? That's literally my life as a doctor, is to say, hey, this could happen, but here's the real life situation. What do we do and kind of fit that? And that's where a lot of people are confused, right? Because they say, hey, this study said maybe it's cancer, but the other studies say like it's clean. So that's really where it comes from. But understanding those are two very different things. That like a possible hazard means like, yeah, if you did enough of it, like it could probably do something bad to you. And that's like almost everything we consume, right? Like, yeah, if you just drink gallons of water every day, like you're probably gonna have a bad time and can lead to hyponatremia and all these bad things. And so a lot of times the dose is the poison. I know like that's a cop out, but that's a very real thing. And then kind of going as well, talking about this, there have been looking at those plant-derived sweeteners, those natural ones like stevia and monk fruit, and major global regulatory bodies like the FDA, we talked about before, EFSA, they've all independently reviewed data and concluded that purified stevia essentially are not carcinogenic or genotoxic to their knowledge yet. So they say that's pretty good. And similarly, monk fruit, standard toxicology tests have shown that monk fruit extracts are not genotoxic, don't seem to increase the risk of cancer at all. And so for purified extracts of stevia and monk fruit approved for use in food, the consensus of regulatory agencies worldwide is that they don't pose a risk for cancer. So once again, you're going to see kind of a common theme here that these are probably going to be safer, better options, safer in air quotes, meaning like, is it really a safer option? Who knows? But we tend to see time and time again, those probably have better outcomes here. And next, I want to talk about cardiovascular risk, right? So that's a big thing. While cancer has definitely dominated the historical fears, the most compelling scientific concerns have actually recently shifted towards cardiovascular health. So the evidence here is newer, more mechanistically plausible, and supported by different lines of evidence. So they're kind of interesting. So the first thing is erythritol. I want to talk about this. So there's kind of this erythritol thrombosis hypothesis. So a big research paper kicked off by 2023 study in Nature Medicine. It was interesting. This research provides a powerful 3-part case linking possible erythritol to blood clot risk increase. So first they had observational data, right? So in large studies of thousands of patients undergoing cardiac evaluation, higher circulating levels of erythritol in the blood were strongly associated with high risk of future heart attack, stroke, and death. The results were consistent. Individuals in the top 25% of blood erythritol levels had roughly double the risk of those major adverse cardiac events over a 3-year follow-up. And then so with these observational studies, next we have mechanistic data. So the researchers then established a plausible biological mechanism for this link. The in vitro experiment showed that erythritol at concentrations, decently high concentrations, but theoretically possible in human diets, they enhance platelet reactivity and aggregation, the key to forming blood clots, right? So platelets are really important for blood clotting, but also for causing things like heart attacks, right? If you have platelets clot up in where they shouldn't be and cause a blood clot, well, that could be an issue. And then also they also had human intervention data. So with kind of also a caveat I have to talk about. So the final piece was a human trial where 8 healthy volunteers drank a beverage sweetened with 30 grams of erythritol. So 30 grams. So they just kind of like threw that in there. Like 30 grams is a lot. It's really critical to understand this is a high dose. So while the study notes that it can be found in certain commercial products like a pint of keto ice cream or some sugar-free baked goods, it's the equivalent of consuming many individual sweetening packets at once. So it's just like someone just upending packets, putting it in. So it's a pretty high dose, but it's understandable. We want to see, is there signal to this noise? So I'm not like faulting them at all, but it's pretty high dose. But they found that this single dose caused a dramatic 1,000-fold spike in plasma erythritol levels. And these levels remained highly elevated for 2 to 3 days, staying well above the threshold shown to promote clotting potential. So that's kind of interesting there. And more recent data from the same research group has also found similar results for xylitol, potentially another common sugar alcohol, suggesting a possible class effect. So erythritol, xylitol kind of connection there. And other large studies have also looked at artificially sweetened beverages as a group. So there was a cohort study found consumers of artificial sweeteners had an 18% increased risk of cerebrovascular disease or stroke, and aspartame was specifically linked to higher stroke risk. The Women's Health Initiative found that women drinking 2 or more of these artificially sweetened beverages per day had a significantly higher risk of stroke, and particularly ischemic stroke. But it's really kind of important to understand the primary limitations to these large cohort studies, right? So they show association, not causation. I know that sounds like cliche, like, oh, it's can't prove causation. Well, that's true. In these observational studies, we don't know. And a lot of times there could be something called reverse causality, meaning individuals who are already at a high risk for cardiovascular disease, like those who have obesity or metabolic syndrome, they're the most likely people to switch to diet drinks and try to improve their health that way. So they are the most likely people to be drinking these drinks or with artificially sweetened. So in this case, the sweetener use is kind of a consequence of pre-existing high-risk states, not the cause of future heart attack or stroke. So these people who are already at high risk are on these different sweeteners. So when they're saying, oh yeah, it seems to be like the people who consume this have higher strokes. Well, yeah, because they're at high risk to begin with. That's kind of interesting. So it does create an issue though. The very patient population most often advised to use these non-nutritive sweeteners, people with obesity, diabetes, metabolic syndrome, it's the exact same population already at the highest baseline risk for thrombotic events. And, theoretically, sugar alcohols, xylitol, erythritol could facilitate that. That's kind of one takeaway there that, okay, maybe we should watch out with those. But yeah, that's what we're looking for. And next, I'll move on to weight and diabetes, right? So another main use of these sweeteners, right, is to manage metabolic diseases like obesity and type 2 diabetes by providing sweetness without the calories or a glycemic load, right? However, the scientific evidence supporting this is deeply paradoxical, creating a major conflict between the different types of studies. So overall, in May 2023, the World Health Organization issued a big statement and guideline that sent shockwaves through the public health community. I saw, online health people and social media going crazy about this, right? They recommended that non-nutritive sweeteners should not be used as a means of achieving weight control or reducing the risk of non-communicable diseases. So essentially they're saying, hey, don't use them as a main reason. And what's kind of interesting is because in short-term randomized controlled trials lasting from a few weeks to a few months show that when these non-nutritive sweeteners are used, when they directly replace sugar, they can lead to small expected reduction in body weight due to a net calorie deficit. And this is a simple substitution effect, right? If you're consuming a butt ton of calories and then you switch to a sweetener and you eliminate those calories, you're probably going to have a good time. So, it's going to be helpful for you. But then there's also these long-term observational studies, right? So in contrast, large prospective studies tracking people for many years suggest that higher habitual intake of these sweeteners is associated with an increased BMI and higher risk of developing obesity. And so it's like, what's going on there? And so what was the WHO's actual rationale? Informing public health policy, the WHO prioritized the findings from the long-term studies, believing that they better reflected the real-world impact over a lifetime despite the high risk of reverse causality. Like we mentioned before, like, hey, long-term studies had increased BMI and risk of increased obesity. Well, yeah, because once again, the people taking these and using these sweeteners are people who already have these risk factors. And so, people were up in arms saying, what, we should absolutely use them. I think it's pretty clear that like if you swap up, if you're just drinking like 7 cans of Coke a day, like switching to 7 cans of Diet Coke is probably going to be net benefit for you. Like that's like pretty standard, probably going to be good for you. But like, are you going to always do that? Are you going to go back to it? And so there's so many confounding factors. So that's why people were up in arms. I understand why the WHO did that though. It's like saying like, well, we don't see the data that it's actually working, but like common sense tells you like it's probably net positive, but that's neither here nor there. But there's also an interesting paradox for blood sugar management, right? So there's definitely evidence and there's very clear evidence when consumed alone, non-nutritive sweeteners, including stevia, monk fruit, all the artificial ones, they do not raise your postprandial blood glucose or insulin levels, right? So that's a big thing. You get that sweetness, but not that insulin and glucose spike. And this is really, really important and they kind of behave not like traditional sugar, right? But the long-term evidence shows mirroring the data on weight, long-term observational studies consistently report a strong positive association between high habitual consumption of artificially sweetened beverages and increased risk of developing type 2 diabetes. And so that's interesting, right? So this association is plagued though, right? By reverse causality. Once again, the people with prediabetes or the risk factors are most likely to start these sweeteners, making it impossible to prove causation from this data alone. That's very, but there are plausible mechanisms for how these sweeteners could cause harm, right? So the concerning long-term associations have spurred research into how this could possibly be happening. And so there's a couple main ones here. So the first hypothesis is disruption in learned response or appetite regulation. So the body has evolved to kind of have this, associate sweet taste with an incoming source of calories. So it's hypothesized that by repeatedly providing intense sweetness without the expected calories, these sweeteners kind of disrupt this learned response, creating a metabolic confusion, which can impair the body's ability to regulate appetite and energy intake from other foods. Meaning, hey, we're not getting the normal calorie load after sweetness, so therefore something's wrong. And then that's one idea here. The intense sweetness may also heighten a person's overall preference for sweet foods, meaning like, oh, I like that, I want more of it, undermining otherwise healthy eating patterns. So saying, hey, I like sweetness, I'm gonna eat other things that are sweet as well. Another mechanism they talk about is potentially altering the gut microbiome, and this has emerged as a leading mechanistic pathway, and we'll talk a little bit more about that. That's a big topic that we really pretty much know nothing about definitively, but it's interesting. And then also it may have direct effects on gut hormone secretion. So sweet taste receptors, identical to those on the tongue, are also located throughout the gut. It's possible that these sweeteners could directly bind to these throughout the gut and influence metabolic signaling pathways, although human data is kind of inconsistent. But these are the ideas that, hey, maybe that we're disrupting the learned response, maybe it's altering the microbiome, or it's affecting gut hormone secretion as well. So there's some mechanistic plausibility for what could be going on. And speaking of gut microbiome, this is another big issue we talk about with non-nutritive sweeteners. So the gut microbiome is not a passive bystander. Right? We've learned a ton about this in the last decade, but it's an active participant in our health, right? It's essential. It's essentially like an extra organ, right? It's an essential organ responsible for the initial breakdown of plant-derived sweeteners like stevia, monk fruit, all that stuff. And this complex ecosystem is critical for digestion and vitamin synthesis, immune regulation, and like absorption of like everything is just super, super important. And the idea is that these non-nutritive sweeteners might create dysbiosis, right? So it's important to point out that dysbiosis, though, is somewhat of a vague term. It's in the scientific community, it's hard to define dysbiosis because there's no single universally agreed upon definition of what a healthy or unhealthy microbiome looks like. It's highly individualized, right? We learn that different people have different microbiomes. Generally, it seems like diversity tends to be helpful, but yeah, the term refers to an imbalance in microbial community inside the gut. And it's linked to a wide range of diseases, including obesity, type 2 diabetes, cardiovascular disease. But once again, very, very hard to like lock down what that means. But the microbiome provides a plausible mechanism that could unify many of the paradoxical observations we have, right? Acting kind of as this transducer that converts these non-caloric compounds into biologically active things that affect our physiology. So that's one thing we can think about. So what do these sweeteners do on our gut bacteria? Well, the impact varies depending on the sweetener's chemical structure and how much reaches the colon. So saccharin and sucralose have the most consistent, though not universal, evidence for inducing dysbiosis in some animal and human studies. A landmark 2014 study in Nature showed that saccharin caused significant quote-unquote dysbiosis in mice, whatever that is. But then we talk about aspartame. Aspartame completely almost completely metabolized in the small intestine, meaning very little reaches the colon to directly interact with the microbes. So the evidence for its impact is inconsistent on the gut microbiome. Things like stevia, although directly metabolized by gut bacteria, the balance of evidence for human studies indicate a relatively neutral effect. So there was a 12-week RCT I saw that found daily stevia consumption did not cause significant changes in the overall composition or diversity of the gut microbiome. And what about monk fruit? Well, human data is extremely limited here. However, preliminary in vitro and animal studies are intriguing, suggesting a potential benefit or prebiotic-like effect, possibly by promoting the growth of beneficial bacteria. It's promising, but requires lots and lots of more studies, but it doesn't seem to be a net negative. It could be potentially positive, but I mean, really if it's neutral, that's like probably pretty good for these things. I'm not too worried about positives because we're not going to be able to show that, but it can be very, very challenging. But the critical question is how these changes, like these induced changes by the sweeteners, can lead to adverse health outcomes. And we're not sure, but in that previously mentioned 2014 Nature study provided a powerful demonstration of this link potentially to glucose tolerance, right? So mice fed saccharin developed marked glucose intolerance. Crucially, when the gut microbiome from these mice were transplanted to germ-free mice, the recipient mice also developed glucose intolerance, meaning, hey, they're taking the gut microbiome from the study to clean sample, and they still had that insulin resistance, indicating, hey, the gut microbiome is probably playing a legit case on this. And another key finding from this research is that affects these sweeteners appears to be they're highly personalized, right? An individual's response depends heavily on the unique baseline composition of their gut microbiome, which explains, like, once again, why there's lots of inconsistencies in there. So pretty much if you're looking at studies, just like blame it on the gut microbiome. You can just be like, oh, gut microbiome, it's off. I don't know. And probably there's some merit to it as well. But yeah, that's interesting there. What's going on there? Not entirely sure necessarily, but we'll keep going. Next, I want to talk about the kind of the regulatory status of this and why health agencies disagree. And so a major driver of the confusion is apparently conflicting guidance, right, on these sweeteners from major global bodies like the FDA, the European EFSA, and the World Health Organization. And this divergence isn't necessarily a contradiction, but a reflection of the different questions each organization is really looking for, right? So as we think about, so the FDA and the EFSA, their goal is focused on toxicology, right? To ensure the safety of the food supply rooted in the principles of toxicology, meaning, hey, well, let's not poison our people. That's like their main goal. And they ask the question, is this substance poisonous or carcinogenic at its intended level of use? And so they review extensive animal studies to find the highest dose with no adverse effects. So they'll say, what's the highest dose we can have in animals? That has no effect. Then they divide this level by a large safety factor, typically like 100, to establish a very conservative, acceptable daily intake for humans. And so based on this rigorous toxicological framework, they have concluded that all these different approved sweeteners are safe for the general population as long as consumption remains below that ADI, meaning, hey, we should be good if you just kind of keep it at that recommended level. Then we have the WHO, which is more broader public health, right? So their whole mandate is to provide evidence-based guidelines that inform public health policies to reduce disease at population level. So their question is, are these effective tools for achieving weight control or reducing disease risk in the long run? And their conclusion, as we mentioned before, they recommend against using these for weight control, just because it seemed like their long-term efficacy didn't seem to pan out. And it was not a statement about their toxicological safety, meaning, hey, they're not saying, oh, they're not safe. They're just saying, they don't seem to do a whole lot, which like is interesting. They prioritize the long-term observational data, which showed a lack of benefit. And at the end of the day, like, that kind of makes sense, right? Because obesity is like, we know this chronic disease, right? So people, they make a change, right, for non-nutritive sweeteners. Like, do we really think that's going to like drive the boat and be like, oh, that's going to do it? Like, that's the number one thing that's going to make me, not struggle with obesity. Like, that's not going to be the case. And so it makes sense that, yeah, we don't see long-term, like they're miracle drugs, because they're not, right? They're just maybe making these small lifestyle changes and maybe helping you in the long term, but it's not like a huge definitive that's going to happen. But next, talking about monk fruit. So monk fruit is actually interesting because it kind of highlights this divergence of regulatory philosophies, right? In the US, the FDA monk fruit extract is considered generally recognized as safe, right? So the manufacturer is responsible for convening experts to prove its safety, and the FDA reviews this determination. Once again, this is the whole problem. Like, a lot of times the FDA, if it's not a pharmaceutical, if it's just a supplement, you pretty much like assume it's safe. Like, yeah, it's good. And hopefully it just doesn't hurt anybody. And hopefully you have someone legit making it, but that's neither here nor there. But in Europe, in the EU, the EFSA, monk fruit is a novel food requiring a stringent proactive safety assessment before it could be sold. In 2019, the EFSA panel concluded that the available toxicological data was insufficient to establish, and they're saying, hey, there are gaps in the data. And as a result, it remains largely unapproved in the EU because, like, yeah, they just didn't think it was there. But the key takeaways here is understanding there's distinct mandates because they have different questions they're answering, right? So the FDA essentially wants to prioritize, is this safe? Whereas the WHO prioritizes long-term data, meaning, hey, does this work for its intended purpose in the real world? So that can be interesting. But a substance can be deemed non-toxic by one agency while also be deeming not effective for long-term benefits by the other without any contradiction, right? So it's not like, oh, they're good, bad, they can work together, and that's kind of what it is. But I kind of want to bring it back here and talk about the clinical implication from this, right? So moving beyond good and bad. The most effective approach is to move past a simple safe or unsafe verdict and engage in a nuanced patient-centered conversation, right? Like, I sound like a broken record because I say it all the time, but everyone's going to be different. Everyone's going to have different risk tolerances and desires and goals. And so we work with that. So a one-size-fits-all recommendation is pretty much inappropriate here. So for patients specifically, though, because what I mean by that is, if you're a normal, healthy person, we have a lot of things we can talk about, and like, will it matter or not? But like, there are some certain populations where it's probably not going to be the same. So if you are a high risk for cardiovascular disease, right, history of heart attack, stroke, otherwise high risk, it may be worthwhile thinking about, hey, let's think of other options, right? So a direct message of caution, I'd probably give them, say, hey, like, we probably want to avoid these sugar alcohols, right? Like erythritol, xylitol, like probably try to avoid that if possible. That'd be helpful. The evidence linking these to potential thrombotic states, yeah, it's somewhat concerning. Not in that like they show like, oh man, it's going to cause massive heart attack. It's just like, hey, let's just probably use something different. That's probably what I'd say. And at the end of the day, I probably like would say that for most people now. It's like, hey, we have this data, like, let's just try to use something different, which is interesting. Same things though for a patient with obesity or type 2 diabetes. acknowledge that these can be useful in the short term, right? But data is not necessarily there long term that's helpful. I kind of view them as a bridge, right? To help wean off of sugary products. If you're used to having, I had a patient one time, I literally, he was diagnosed with diabetes, and it turns out he was drinking like 10 like fountain drinks of pink lemonade a day. So like those huge cups of like just pink lemonade all day. And he had, A1C over 14, literally just switched it to something with a non-nutritive sweetener, and his diabetes A1C went down to like 7. So it was like crazy the impact it can make. And he had good results after that. But yeah, so it can make a huge difference in some patients, like in those extreme examples. But I never want to belittle them and say like, oh, they're not worth anything. Because I've seen firsthand, like in a patient, it drastically changed their life and outlook. But we have to kind of think about that and talk about it. But it is a tool, I think, to help. And, going to tell them, hey, may not be the most important thing long-term if we're making minor, like if you have like one regular soda a day and then switch it to diet, like, I don't know if that matters, but maybe it has to be more extreme, like the case I talked about. But yeah, it's overall something to think about. And once again, these people, I'd probably say I'm probably staying away from erythritol and xylitol, but that's it. But for the generally healthy, I think overall that on occasion, moderate consumption of these sweeteners is likely to not do anything, not cause significant harm. And the fear of cancer from approved sweeteners is largely unsubstantiated by human evidence. And the focus should be on moderation, overall dietary pattern, right? Not habitual high dose consumption, right? So I'll ask people, what are you drinking? What are you doing? If they're saying, hey, like, yeah, I'm down in like 10 Diet Cokes a day. Okay, like we might talk about that and kind of understand what's going on there and kind of get a better, maybe health promoting diet. But I think for the occasional use, like it's probably not gonna be that big of a deal. But another actual takeaway I want to talk about is making sure you read the label, right? The most critical piece of advice for any consumer is to ignore the front of the package and the marketing and turn the product over, right? So I just want to give an example here. For a product branded stevia or monk fruit sweetener, it may contain only a small amount of that ingredient, right? With the vast majority of the product being actually erythritol. As I mentioned before, I kind of tease this saying, hey, you might have a bulking agent of stevia or monk fruit with erythritol. So you're saying, hey, this natural thing is better for me, but it's got erythritol, which is like the one we're talking about, which is like actually one with evidence that it might be bad for you. It's kind of a contradictory thing. So the simple act of label literacy is key to managing a truly informed choice, meaning, hey, let's kind of get there. And ultimately, though, the most effective clinical strategy is to pivot the conversation, right? Away from like, hey, we need sweetener things. Which one's safest, to like, why are we eating these all the time, right? The common denominator between high sugar intake and high sweetener intake is the idea that we need to have sweetness, right? Intense sweetness all the time. And the real conversation should be, how can we work together to reduce the overall preference or reliance on sweet tasting foods and drinks, right? Because overall, if we're doing sweet, it's probably not a fantastically balanced diet. Once again, I'm not saying you can't do that once in a while, but if you're just like, I need sweetness, the question is like, maybe we need to like calibrate yourself to like whole foods, right? Because whole foods aren't necessarily that sweet all the time. Fruit's about as sweet as it gets. And these are like hundreds of times sweeter than fruit. And so, eating our regular whole, plant-based or whatever you have, or whatever diet you have, like those are typically not very, very sweet diets, right? If you have a Mediterranean diet, not very sweet, whole food, plant-based, keto, whatever, not very sweet necessarily. So we might have to scale that back, and kind of reframes this entire issue from a, I need this to like, why do you need this at the end? But the goal is to kind of help recalibrate the palate, right? And appreciate the natural sweetness of whole foods and make unsweetened beverages, primarily water, the default choice, right? So that's my big thing, is like, we don't need to have flavor all the time. That's kind of goes, but not everyone's the same. But I think that's kind of an interesting topic here. But I just wanted to talk about sweeteners in terms of, do I think they're the devil? No. Do I think they're the healthiest thing in the world? Like, probably not. There's probably something out there too there. The biggest thing for me, I'm pretty much like the most boring person in the world. I don't eat a lot of them. With yogurt, sometimes I will, when yogurt's really sour. That can be reasonable to have yogurt in there. It's not a big part of my diet, but I think overall that's to be the main goal, right? It's never a huge part of your diet. And if it is, then we might have to reassess. If it's an occasional thing, you're probably okay. But understand the risks, right? Nothing we take or consume is without a risk, that's for sure. And so we just kind of have to weigh those balances there. But that is going to be it for today. Thank you so much for stopping by. I really appreciate it. If you did enjoy this podcast, it would mean the world to me if you either share this with a friend, left a 5-star rating on your podcast platform of choice, or subscribe on YouTube. But that's it for today. Now get off your phone, get outside, have a great rest of your day, and we'll see you next time.